Hey students, in this video I'm going to quickly go over the example side of the review for you to use tomorrow during class or just review over quickly before class. This first example on the left side is going over the type of solutions that we have. So when we first learned this, we learned that there are three different types of solutions to a system. You have one solution image where all three planes are meeting at one point, or the no solutions where all the planes are maybe intersecting, but not all three at the same time. And then the infinite solutions, which is where all the planes are intersecting more than one point, at more than one point. So this image right here is demonstrating the example of infinite solutions because all three planes are intersecting at more than one point. So make sure you guys answer the question and justify with an explanation to verify that you truly understand why. The next problem, it's asking to solve the following system, and these three equations are set up in a way that you could solve through substitution. Substitution method was the first method we learned algebraically, and it was again recognizing the setup of the equations and seeing that when it's set up this way, you could quickly substitute the values as you find them. So the equation with the one variable can be solved first, then you substitute that value into the one that has two variables, solve for the other, and then last use the one that has all three variables to solve for the third variable. So that's the setup for this. I would strongly encourage you to pause the video and try it on your own, then check if your work matches this. But if you want to just pause the video and check my work and follow along, you can. But again, this is a review. So we're just solving for the equation that has the x variable because it's by itself. That gives us 5. Then you substitute the 5 in there to solve for y. So this is the process for that. And we ended up with y equals 2. Once you have x and y, you substitute x and y in here, and then you solve for z. So that's the process right here, and z was positive 1. So these are the three values for the solution. On the next problem, it's asking to check if the ordered triple is a solution to the system. So when we did this in class, we practiced substituting the values and checking yes or no if it was true or false. You could either do it by PEMDAS or typing this in the calculator and checking if it's true or false. Just be careful with the typing. If one of the equations is not true, then you will say no, it's not a solution. If all three are true, then yes, it's a solution. In this example, when I substituted the values in the first equation, it was true. We got 24 equals 24. However, when we substituted those values in the second equation, and it showed a false statement at the end, that means this triple is not a solution to the system because it's not a solution to that second equation. It's not true. All right, the next one is solve the following system of equations. So the setup on this one is once again for substitution, but for time purposes, I went ahead and did the calculator method, which means we need to convert this into a matrix. But first, you need to verify that x, y, z are on the left side, and then it equals the number. So x, y, z on the left side, number on the right side, letters, variables on the left side, numbers on the right side. All of them are ready to be written in a matrix. So when we wrote them in a matrix, carefully put the zeros where you don't have variables. The top equation does not have a y, so notice that we put a 0 on the y. The second equation does not have a y and z, so notice we put a 0 on the y and z. And then the last equation did have all the values, so we just wrote them all. Following the strategy of the calculator, we did the RREF, typed in the matrix, pressed enter, and it gave us this format right here. So we triple check that all the ones are there diagonally. If they are, we conclude that this is our solution. The 7, -1, and -4 is the solution here. So in case you forgot about that, your notes do have those options right here. So if the ones are diagonal, you have one solution and you have your solution right there. If there is no ones diagonally all the way across, you have a special case where you will write a statement where nothing equals that number. And that would be a false statement because nothing equals nothing. So if it's false, it's no solution. And this is an example of what I meant about nothing equals nothing. There's nothing on the left side, there's nothing on the right side, so 0 equals 0, which is true, and it's infinite solutions. So based on the calculator method, we could either have all ones all across, or zeros all across, or zeros partially across. So just be careful with that. In the back of the review, we have another scenario, solve the system. So once again, for time purposes, this one needed to be done algebraically with the Gaussian elimination method, but we know we're not fans of that because it requires so many steps. So instead, we just stick with the calculator method. So double check that x, y, z are separate from the numbers. So x, y, z on the left, x, y, z on the left, x, y, z on the left, numbers on the right. Type the values in the calculator as a matrix. And then here is that, my version of typing those numbers in and pressing enter, and it gave me that matrix, this matrix right here. The ones are diagonal, which means that we do have one solution, and 1, 3, 1 are the values for your solution. On the next problem, similar to what we just did, however, this is not in order of x, y, z. We have to make those changes before we write the matrix. So after making those changes, this is the matrix we got. And we use the calculator, this one on the bottom, and typed all those values in, and then that's the solution we got. So notice how this one does not have the ones all the way across. It is a special case. It has zeros all the way across. And when it's zeros all the way across, we have a true statement of 0 equals 0, which means it's infinite solutions. Last problem in the review is a word problem. So that's the last topic we did in class. You read the scenario, you look for the question. What is the question asking? Identify the 3 things that the question is asking you to find. So how many acres of each crop did the farmer plant? If you go back to the beginning of this problem, it says that there's corn, wheat, and soybeans planted. So those are the X, Y, Z. It does have information spread all over, so you just gotta identify. I color coordinated it for you. Hopefully this helps. If there's a farm that has 240 acres, that means that all the acres combined will equal 240, so that's one equation. Then it says that the farmer planted the same, and the hint is same, meaning equal, number of acres of corn as the combined number of acres of wheat and soybean. So corn is the same as the combined of wheat and soybean. And this is what it looked like. Corn is X, and it equals the same as the combined of wheat and soybeans. So Y plus Z equals dx. The last one is the number of acres of wheat planted was triple the number of acres of soybeans. So if you're looking at the land, we're looking at wheat being more than the soybeans. So we're going to have wheat, Y, is triple the number of acres of soybeans. So 3 times the number of soybeans. So 3Z. So this is the 3 equations. This is the system that we get from this word problem. I know it was a rush video, but again, I was just summarizing the left side of the review. Hopefully this helps you.